We conduct some sort of test involving involving the student's t distribution. The degrees of freedom is just n minus 1, so 50 minus 1 gives us 49. And so for part B, if this question we're asked to find the critical value, so I'm actually going to use stat disk over here. Let's see. Of course, every time I go into it, I freeze. I'm like, oh, where is it? Probability distributions, and then student t distribution. So if you follow that path, we have we're looking for a t value for degrees of freedom of 49, and so we're supposed to enter one value. It's a 95% confidence interval. So if you were to draw out, the normal distribution, they want to have 95% in the center. That means you get 2.5% in the left tail and 2.5% in the right tail. So I'm going to put in the decimal form of that percentage. That's 2.5%. If you click evaluate, then it spits out the t value. We just need to round that to 2 decimal places. The other way of doing this is using a table in the back of a textbook, using a student's t distribution table. They're available online. Usually it takes a little bit longer because you got to sift through a whole bunch of numbers. But part C says give a brief general description of the number of degrees of freedom. So there's some analogies out there that are pretty cool for interpreting the degrees of freedom. And one of the analogies goes, like let's say you've got a data set where the mean of the data set is like 10. Okay. If you were trying to calculate a new data set that still had a mean of 10, well, you could give me the first number, you give me the second number, give me a third number. But if you're calculating a mean, you don't have any freedom about that fourth number, right? Because given 3 numbers, you have to have a certain value for the fourth number in order to still get a mean of 10. So degrees of freedom is the amount of numbers in your data set that can fluctuate when with respect to the sample mean. When calculating a mean, n minus 1 numbers can fluctuate. So in this case, 49 numbers can fluctuate, but once you get to that 50th number, it's not free anymore. It has to be a certain number. So let's see which one's best here. Number of degrees of freedom for a collection of sample data is the total number of samples, and that's not true, right? That would be n, so that's not it. B, the number of degrees of freedom for a collection of sample data is the number of sample values that are determined after certain restrictions have been imposed on all data values. It is a restriction we're imposing, but it's not a restriction on all data values, so that's not quite it for B. For C, the number of degrees of freedom for a collection of sample data is the number of unique, non-repeated sample values. That's not it either, right? Because we have 50 numbers here. Oh no, they just give us a t. Yeah, we don't know what the 50 numbers are, so we don't know how many are non-repeating. Whether the numbers repeat or not is not the issue. Yeah, so the big difference between B and D here is that B says the number of samples that are determined after certain restrictions have been imposed on all data values. The samples we gather are randomly selected, right? So we're not picking certain people for our sample. The number of degrees of freedom for a collection of sample data is the number of sample values that can vary. It's like that analogy at the beginning, like the first number that can vary. You could make that 100, and still eventually you could calculate a sample mean of 10. The second one, that can vary. The third number, that can vary. But the fourth number has to be a certain value based on those other 3 in order to calculate a sample mean of 10. So that's tricky. Degrees of freedom's probably one of the hardest concepts in the statistics class that I have a hard time, explaining in an easily interpretable way. But stick with it and message me if you have any other questions.